Welcome to another video from ExplainingComputers.com. This time we're going to build a PicoMiteVGA. What's that, you cry? Well, a PicoMite is a Raspberry Pi Pico that runs the Basic programming language created by Jeff Graham. And back in 2022 I built a PicoMite on the channel and it worked very well indeed. However, a PicoMiteVGA is even more exciting because it adds a VGA port, a PS2 keyboard socket and an SD card slot to the Pico, so it can be used as a standalone boot to basic microcomputer. Now, building a PicoMiteVGA is going to be, for me at least, a bit of a voyage of discovery. It's going to be a journey as I find out the best way to source the components and to put everything together. So, let's go and get started. Right, here we are on the PicoMiteVGA page on Jeff Graham's fantastic website. And if we scroll down here, we can learn more about the PicoMiteVGA, particularly under the VGA output section. It tells us that the VGA output is 640 by 480 pixels in monochrome or 320 by 240 in color mode, which is 16 colors. And one of the really clever things here is that the VGA output is generated using the second CPU on the RP2040 on the Pico. The Pico has got two processor cores, so it uses one for VGA and the other to run the basic interpreter, which means it can run that at full speed. That's a very clever piece of design. Anyway, if we scroll down a bit further, we get a picture of the PicoMiteVGA. There it is. And if we go right to the bottom, we find lots of downloads, including a fantastic manual for Basic that really is very detailed indeed. We find the firmware we need to write to the Pico to build the PicoMiteVGA, and we find the PicoMiteVGA construction pack, which we can download. And guess what? I've downloaded this already and extracted the files, and here they are. And it seems there are now 4 different designs available. So for example, design 3 is getting quite sophisticated. Let's just look at a picture. Here we are, there's design 3. This I think has got a micro SD card slot. It's got a power jack to power it rather than using the USB connector on the Pico. But I think I'm going to stick to the original design, design 1 over here. Have a look at that, like that. This is what I'm intending to build. So we find here we have lots of useful information. There are some construction notes which show everything plugged in, as you can see. This lists all the parts we need. A bit of information on assembly, but basically it says assemble the thing, which is fair enough. It gives you all the details of the parts and the PCB. And also available here is a schematic, a really critical thing, so we can see exactly what's going on. Let's just zoom in a little bit. So we basically see we have the Pico connecting to the SD card. That's relatively simple, basically wiring. It connects to the VGA connector over here. Let's come out a little bit so we can see that better. There we are. And this requires a reasonable number of components, lots of resistors, a couple of diodes, a little trim pot over there. And then up top here we see the PS2 keyboard connector, which requires again some resistors, a couple of MOSFETs, metal oxide semiconductor, field effect transistors. So this is not a massively difficult electronics project, but it requires a reasonable bit of care and sourcing of parts and putting them together. So to build a PicoMiteVGA, there's a fair amount to do, and what I discovered is if we go across to the web again and go to here, siliconchip.com.au, there is a kit available for the PicoMiteVGA. And this kit includes the PCB, the printed circuit board, it includes a Pico, it includes all the parts, which are nicely listed here with little pictures. That's really, really good. And this kit costs 35 Australian dollars, which is about £20 in the UK or about 24 US dollars. I think that's very good value indeed. And so straight away I thought, this is what I'm going to do. I'll buy this kit. I put it in my shopping cart. But when I did that and went to check out, unfortunately, I got this message here, which says that due to sales tax regulations, they cannot sell goods costing less than 300 Australian dollars to customers in the UK. And given that building a PicoMiteVGA is supposed to be a fun, low-cost project, whilst the kit here does look excellent for those who can buy it, I need to find another way to do the build. Right, I've decided to buy individual components from CPC Farnell, where I've already located the diodes, the trim pot that's used to adjust the VGA output, the capacitor, and also the MOSFETs. And I've been rummaging in various boxes, and I've discovered I already have the required 7 220 ohm resistors and 4 10k resistors. However, I'll provide links for suitable resistors along with everything else I'm using in the video description. We're also going to need a circuit board, and I did consider getting one made using an online service, because if we look in the PicoVGA construction pack, there are Gerber files for that purpose. And in fact, I checked it out. I went across to JLC PCB, uploaded the files. Clearly it would have worked. It would have cost, it seems, $7.20 plus shipping. And in the end, I decided, although the cost for the boards was pretty good, the shipping was going to push the cost up considerably unless I waited a very long time for the boards to arrive. And so in the end, I've decided to build the PicoMiteVGA on something I could buy from CPC. And I'm going to use this as solderable breadboard. And this raises one specific issue, which we can see if we look back to the custom circuit board. There's a picture of it here. And if we look here, we can see there are specific hole and pad combinations to fix on the specified VGA socket and also the PS2 socket and the SD card slot. And these exact configurations of pads and holes are not going to exist on our solderable breadboard. So what I'm going to do, I found a solution, I think. I've gone across to Pimoroni, where I'm going to be buying my Raspberry Pi Pico, and I'm going to get one of these, a breakout board from microSD card. Not too expensive, we'd have to buy an SD card slot anyway, and as we can see here, this clearly works on a breadboard, so it'll work on our solderable breadboard. And I've also come up with a solution for our VGA and PS2 socket, which I'll show you in a second. But for now, I need to get on with doing some orders, both from Pimoroni and from CPC, and I'll come back to you when these orders have been delivered. Greetings! Everything has now arrived, with the total cost of all of these components being £33.25, including delivery here in the UK. And I think this is the lowest price I could have achieved for this build. Although on top of these parts, we'll also be adding in the 11 resistors I mentioned earlier, this push switch to use as a reset button, and necessary connection wires. And this will add a few more pounds to the total price. And here we have a full list of all the parts and suppliers that I've used. So let's use the magic of filmmaking to remove the packaging so we can see the individual components more clearly. And here I'd note there was a minimum order quantity of 5 for the diodes and for the capacitors, so we have a few more of these than we actually need. And it's also worth noting I bought a Raspberry Pi Pico H. This is a Pico with pre-soldered headers, and I bought this because it was cheaper to buy the Pico H with the pre-soldered headers than to buy a standard Pico and to buy headers to actually solder onto it. This said, I have bought these headers. These are stacking male-female headers, and these will allow the Pico to be plugged into our PicoMiteVGA. It'll be removable, and so you don't have to use these headers. These are optional parts. Over here we have our solderable breadboard, which is good and solid, and our components will go through on this side, something like that, and they'll be soldered on the underside. And we just take a look under the board like this, and we cut into a nice big close-up. We can see how the pads are connected in a standard breadboard matrix. So let's turn this back over, because my next task is to design a bracket to go on the end of this, which will hold in place our VGA and PS2 connectors and also our reset switch. And the VGA connector and PS2 connector here, these are not surface mount connectors. These have got connections on the back, as you can see if I put them up like that. So I'll be soldering wires to these connectors and then connecting those wires to the breadboard as required. Oh, and the other really important thing I now need to do is to put on my best thinking cap, as I need to translate the wiring diagram we saw earlier into a breadboard format so that I know where to place and how to wire up the components. Right, I've been doing some 3D printing, as you can see, and this has resulted in 3 parts which I've fit tested to our solderable breadboard. 2 of the parts where underneath, as we can see here, these are little sort of foot brackets just to hold things off the surface so that the protruding soldered parts won't scratch things on the surface and cause us any problems with this being, well, uneven on the base. And the other part is here, which, as we can see, holds in place the VGA socket, the PS2 keyboard socket, and the reset switch. And as some of you might have noticed, it's not a perfect 3D print. It's got a bit manky towards the top, but it's good and solid, so I'm happy with that. And down here at the other end, and now I'm going to be mounting the microSD card slot. Let's just put that in place to show you roughly what it's going to look like. There we go. I'm really pleased with that. And of course, other components need to be added in the middle, or this is never going to work. But before I start on that, I thought I'd write the Basic firmware to the Pico. So let's do that fiddly operation where we take the Pico, hold down its button, and plug in a USB lead from a computer, like that. There we go. And if we now go across to the computer, the Pico is mounted here as drive F. There we are. And if we go across to the folder with the PicoMiteVGA firmware, we can take the UF2 file and copy that and paste it across to the Pico like that. That will install Basic. And just to test things are working, we'll now open up PuTTY, where I've already got settings for the PicoMite for my previous PicoMite video. This is expecting the Pico to be on COM6, where one was the last time I used one. All of this is explained in my previous PicoMite video. But if I now just click on Open, there we are. This is looking quite encouraging. Yes, we seem to be running Basic. Let's just move the screen to a more sensible position, like that. If I do print hello, it's printing hello in Basic. But of course it's doing it here in a terminal on another computer. So let's now add some components to our PicoMite so it's got its own VGA display. Guess what? I've finally got around to converting this circuit diagram into a breadboard format. And I started out entirely with a pencil and pen on paper, lots of scribblings like that, and then I moved on to something partially out of the computer because it was getting too complicated to keep it neat, but there's still lots and lots of scribblings on this, as you can see, but I think this now basically works. And what we've got going on here is really three separate circuits, or is three separate circuits connected to the Pico. We've got the circuit for the VGA connector down here. We've got what's called a level shifter up here, which allows us to connect a 5-volt keyboard to the Pico, which runs its logic at 3.3 volts. And we've got the connections for the microSD card slot. And what I've done already is to build the first of these, the VGA section, onto the Pico. It's here. I've been doing some soldering. It's not a lot to say about doing soldering. Here's a shot of soldering. It's very exciting. Take it nice and slowly. Let the solder flow to make good connections. Check each one as you go. And you'll end up with something like this, where we've got the Pico, the trim pots here, all the resistors and the diodes necessary for connecting the VGA connector. And you can see the connector itself is connected up with all these lovely coloured cables. They're even the right colours for RGB, black for the ground cables, and a yellow and orange for the horizontal and vertical sinks. Or is that the other way around? I can't remember. Anyway, what I thought I'd now do is to just go off and do a quick test before I continue. And if you're building something, I would recommend you do that. If you can break it down into stages, build and test each stage. So you're more likely to find an error if you get one, rather than building the whole thing, plugging it in, and then discovering it doesn't work. Greetings! Here I am in the corner of the screen, quite possibly out of focus. I wasn't intending to film this first test, so please forgive me any technical issues in this segment, but it's going so well I thought I'd share the excitement. And what we've got going on is we've got the PicoMite down here connected via VGA to this monitor, and we've also got over here the screen from the computer, which is also connected to the Pico, which is accessing currently by a terminal, just as we were doing earlier. It's accessing via PuTTY. And if I run the program on the system, I put a quick test program in like this, you can see we get some text on the screen. It says this is red text, blue text, green text, etc. It isn't. And the reason for that is we're currently in what's called mode 1 on the PicoMite VGA, which is a resolution of 640 by 480 at 1 bit colour per pixel, so it either has to be white or black. However, if I change to mode 2, like this, there we go, we're now running a resolution of a 320 by 240. Now in fact, it's actually still outputting a 640 by 480 signal, but it's pixel doubling to give us 320 by 240. And we've now got 4 bits per pixel available for colour, 1 for red, 1 for blue, 2 for green, which gives us 16 possible colours on the screen. And so if I now rerun the program like this, very exciting, oh look, we've got colour, it works. And I've adjusted the colour using the trim pot on the board. You basically do a CLS, RGB and a white to bring up a white screen like this, and you twiddle the trim pot until you've got a nice white screen like this. You can do other colours of course as well. We could do, for example, I don't know, we could do red. Very exciting. Or we could do, guess what? Let's do something different. Let's do a cyan. There we are. It clearly works. So as you can probably tell, I'm very excited this is working. So I'm now going to move on to build the level shifter to connect the keyboard, and then we can also add in the microSD card slot and run some more extensive tests. Well, I've finally finished construction and everything's even neat underneath, as you can see, or relatively neat. And back here on the top, we've got the finished level shifter circuit to interface with the keyboard. We've got the reset switch down here, and at the other end of the board, we've got the microSD card slot. And as some of you may wish to reproduce this build, I note that I've shared the STL files for the 3D printed brackets on Thingiverse, and I'd also offer a few pieces of advice. Firstly, your guide should be the circuit diagram and other materials available from Jeff Graham's website. However, here's a diagram indicating the component placement and wiring that I've used for the VGA and keyboard circuits on the solderable breadboard, with this additional diagram showing how I've wired up the microSD card reader. And whilst I purchased this from Pimoroni, it's actually a Pololu product available from many retailers, and it's got a very helpful pinout on the back. When it comes to component placement, be mindful that the diodes must be inserted the right way around, with the cathode going to negative as indicated with a black band. Similarly, the MOSFETs have to be inserted with their source, gain and drain terminals in the right places, which here means that their flat edge is closest to the outside of the board. Finally, I'd note that I've not included a bypass or decoupling capacitor in the SD card circuit, as although this is in the parts list, it doesn't appear on the Design 1 circuit diagram. And having read up, it seems that whilst a capacitor is sometimes needed to reduce noise, often things work fine without one, as is the case here. This said, a bypass capacitor could be placed across the positive and negative rails as close as possible to the card reader. And whilst we're on this subject, note that cards need to be formatted FAT16 or FAT32 with a smaller block or allocation unit size as possible. And here I'm using a 4GB card with a 1024 byte allocation unit. Greetings! I've now got the PicoMiteVGA all connected up, as you can see, from its VGA port to this monitor, from its PS2 port to this PS2 keyboard, and I've also got connected in a micro USB power supply. It happens to be a Raspberry Pi micro USB power supply, but any micro USB power supply will do. This thing doesn't draw a lot of power. So let me plug it in like this. There we are. It should come to life. And it has. And it's working. It boots up very quickly. So if I just take off the numlock mode on this keyboard, it comes on every time it just starts up and I type run. We can run a sample program I've got on the system like that. We can see all 16 colours here available on the PicoMiteVGA. And to show you some more, if I do this, we're now recording the VGA output directly from the Pico. And if I enter edit like that, we can see the program making that output. There it is. And if I press escape, we go back to the command prompt. And there's a couple of things to tell you. First one is the default keyboard layout for a PicoMiteVGA is US, but you can change the keyboard layout. So for example, I entered this command to change to a UK keyboard. Secondly, you might remember we've got an SD card connected to the PicoMite, and the first time you use it, you have to set it up by typing option and a SD card like that, and then telling it the GPIO pins which are in use, which by default are GP13, GP10, GP11 and GP12. And if I execute this command, it'll give us an error like this because it's already been done, but you will have to do it the first time you want to use the SD card. So let's now do just that. And if we type files, it'll show us the files on the card we've got inserted. There we are. Probably best to go back to mode 1, 640/480 mode, and do that again. Files like that. That's a bit easier to see. And we can now, if we wish, load files from the microSD card and save files back to it. You do have the ability to save to flash memory on a PicoMite. There are 8 flash slots, as I talked about in my last PicoMite video. But if you want to get files to or from the PicoMite externally, you have to use an SD card. So let's load in one of these programs. Let's load in the program called blocks baz like that. There we are. That's the program now in memory. We can see that if we press edit, there it is. It's worth noting that the PicoMite runs its programs from flash memory on the Pico, so the last program you were working on is always there when you reboot the machine. And if we now run this particular program pressing F2, it's a game, an exciting game. Let's run it on level of difficulty 9, which is rather fast for me. But anyway, you can see it's a game a little bit like Tetris, isn't it? I'm not very good at this, particularly when talking to you at the same time. But never mind, we will see what we can do. Oh, I got that one in roughly the right place. There we are down there. Oh, yes, I had something happen there which suggested I know what I'm doing, which is probably not true. But anyway, as you can see, it works. You can write some quite impressive stuff using a MMBasic. This was written by Jeff Graham himself, as you might have noticed when we saw the listing. How am I doing? Oh, that'll fit down there, look. That'll fit down there. Oh, I said I couldn't do this. I'm going perfectly well. As soon as I say that, things start to go wrong, don't they? But anyway, I'm impressed with this. It does give you the feel of using an old 1980s computer, says he, losing the game. Anyway, the main thing is our PicoMiteVGA is working very well indeed. I would remind you there's a fantastic manual for MMBasic, so you can have loads of fun programming this microcontroller-based computer. So there we are. We've turned a Raspberry Pi Pico into a 1980s style microcomputer. And I'd like to thank Peter Mather, Jeff Graham, and everybody whose work has made building this a possibility. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.